Lesson 6E, the fundamental theorem of algebra, helps us look at the nature of the zeros and how many zeros a polynomial has. When you first look at a polynomial, if it's in standard form where it's decreasing in degree power, like 3, 2, and then there isn't a x to the first power and then the x to the 0, you know from the fundamental theorem of algebra that this guy could have 3 zeros. Okay. So the first thing we're going to do is use the Descartes rule of sign change and try to figure out the nature of these zeros. So we know our total zeros is going to be 3 because that's what the highest degree is. So you look at f of x to determine the positive real zeros. If you'll notice, this is a -1, and then you go to a +5, and then you stay at a positive. So this has one sign change, okay? So that will tell you the positive real zeros. Now you know it could be 1, and then it could be every even, you decrease in even numbers. So if it was 3, then you would say 1 and 0. If it was 5, it would be 3, 1, and things like that. If it was 4, it would be 2 and 0. So we know from here, since there's only one sign change, that the number of possible positive real zeros is going to be 1. Then what you're going to do is you're going to plug in -x to figure out the number of negative real zeros. So if you plug a -x into a -x cubed, you're going to get a positive x cubed. If you plug a -x into positive 5x squared, you're going to get a positive 5x squared. And if you plug a -x into positive 12, you're going to leave with positive 12. So f of x tells you the positive real zeros. F of -x tells you the negative real zeros. So here, you'll notice we don't have any sign changes at all. Positive, positive, positive. So we're going to have 0 negative real zeros. So if I need 3 and I have 1, then that leaves our imaginary to be 2. And you need to remember that imaginary zeros only come in pairs. So it can't be 1 or 3 or anything like that. Alright, so this is the breakdown of f of x. We're going to have 1 positive real zero. We're not going to have any negative real zeros. We'll have 2 imaginary zeros, and that will total the 3 zeros. Alright, let's come over here and look at example 2. Here we have 1 sign change, 2 sign change, 3 sign change, 4 sign changes for f of x. So this is what I was talking about before. We're going to start with 4, and this number we're going to drop by 2. So we might have 4, we might have 2, or it's possible we're not going to have any. Okay? And keep in mind your highest degree here is 4. So the most number of zeros you're going to have is 4. So then we're going to try to find our negative real zeros. So we'll come up and we'll plug -x into this. But when you raise a negative to an even power, it's going to stay positive. So this is 2x to the 4th. When you raise -x cubed, that's going to be a negative times the existing negative is going to be plus 8x cubed. Negative to an even power will stay whatever it was, which in this case it was positive 6x squared. A negative times a negative is positive 3x. And then we have plus 1. Okay, so we need to figure out what f of -x is. And then we're going to count our sign changes. So positive, 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 positive. There are no sign changes on this one. So we have 0 here. So if we had 4 positive real ones, then, and we have 4 total, that means we wouldn't have any imaginaries. Now if we had 2 positive real ones and no negatives, then that means we would have to have 2 imaginary. And if it ended up that we didn't have any positive real ones, any negative real ones, that means we'd have to have 4 imaginary. So Descartes' rule of sign change helps you figure out the number of real zeros. And since you know the total number of zeros, the difference between the total and the real will tell you how many imaginary you have. And this is pretty helpful when you're trying to graph and you're not sure how many times you will cross the x-axis or where you're going to cross the x-axis or anything like that. Alright, the other part to this lesson is your ability to take the zeros and come up with a polynomial function that gives that to you. So remember that we can only use this rule when you're doing 2 at a time. So if you had to do 3 zeros or anything like that, you would do 2 and then you would multiply in the other one. And the rule here is x squared minus the sum of the zeros, x, plus the product. So if you look at -2 and 4, your sum is going to be 2, and your product is going to be -8. So our polynomial function that has those zeros would be x squared minus 2x minus 8. If you look at this one, we have a sum is 0, and your product is -25. And when you put that into the formula, you're going to be x squared minus 0x plus -25. So this guy would just be x squared minus 25. Now you should remember that anytime you're working with square roots, they only come in plus or minus pairs, and that includes those imaginary numbers as well, because imaginary numbers are the square root of -1. So if you're told that 5i is a 0, then it's understood that -5i is also a 0. They don't have to state that to you. If you are told that 6 plus the square root of 4 is a 0, then its conjugate 6 minus 4 is going to be a 0 as well. So a lot of times they'll only show you 2 zeros, but that means that there's 3 because it's going to be the conjugate of one of them possibly. Alright, so this is actually -2, 4 plus I, and 4 minus I. So you can't forget about that other guy. And so I'm just going to work with these two because I can only do 2 at a time. So I'm going to do that whole sum and product rule. So my sum here is going to be 8. 4 plus I plus 4 minus I. The i's are going to cancel out. My product here is going to be 16 minus 4i plus 4i minus I squared. And we just got finished working with the i's. We know I squared is the same thing as -1. So my product here is going to be 17. So remember, I could only work with 2 at a time. So these two result in the polynomial x squared minus 8x plus 17. And this other 0 over here would be x plus 2. And then I can FOIL this together to get the final polynomial. X cubed minus 8x squared plus 17x plus 2x squared minus 16x plus 34. And that works out to be x cubed minus 6x squared plus x plus 34. And that would be the polynomial that has those 3 zeros. So that's a nice little trick for being able to figure out a polynomial from the zeros.